My name is Daryl Spector. I'm the VP and GM of Promation Nuclear. Kind of a brief history of Promation. Started off in automotive back in the owner's basement, Mark's basement, back in '95, and then was strictly in automotive up until 2007. And then in automotive, the industry started to just totally taper off. But at the same time, nuclear refurbishment started to pick up. In nuclear, it was very traditionally a slow, cumbersome, expensive industry. So for companies like us to come in that were nimble, quick, customer-focused, responsive, schedule-conscious, and budget-conscious, it was very refreshing to the nuclear industry. It was a great opportunity for us. More recently, in the past 5 years, automotive has really picked right back up. Automotive and automation in general, general packaging and so on, but nuclear's continued to grow. So we have, firmly established ourselves in that environment. So now we're in our 23rd year.
We essentially have the coolest job in the entire world. We design robots that go into nuclear reactors that perform tasks that are not safe for human beings to do. The reason why we can do nuclear work is because of our quality programs. That's the reality. And I don't know how many companies in Ontario have those quality programs, but my perception is that there's not a lot. It's not like ISO. So ISO is kind of like the generic, everybody has it. Once you start getting into the 299.1, 299.2, 3 and 4, we have all of them, and the pressure boundary, suddenly there's not a lot of companies that can do the work. And this is the type of stuff that outlines what you need to do to control the quality.
So because of that breadth and diversity, at any given time, we're quoting dozens of jobs, and we're actively working on, I would say, anywhere between 1 and 2 dozen jobs at any given time. This is a really good initiative because, if you ask anybody, how are things made, and if you don't watch it on the Learning Channel or whatever it is, you simply don't know. So we actually design and build the machines and equipment and robots to make stuff. And the great thing is if you can't actually come here and see firsthand, because quite often when else would you have an opportunity to go into a manufacturing production facility, this is the next best thing. So what they will see is, a mix of office environments, like the traditional white-collar workers, and the traditional non-skilled workers, which is like the accounting, administration, HR, things like that, as well as the actual designers who are working at the desks on using computers to design things. And then on the shop floor, they'll see a myriad of skilled tradespeople. What I say is building just a lot of a bunch of neat stuff. We've got robots on the floor, automated machinery, you've got guys machining stuff, you've got sometimes welding going on. And the way I describe it for some of the younger kids, it's almost like building Lego from scratch. So you've got the guys who are quoting the customer, and the customer says, I need a Lego kit, and it needs to do this. Great. So then you start from scratch saying, okay, well now we need to make this Lego kit, and we need to design what this Lego kit looks like. So the guys in the computer will design all the Lego pieces, and they'll put it all together from the mechanical side, and if it needs to move, you have the electrical guys doing all of the motors and the wires and all that kind of stuff. And then, they've got to basically custom make all of their own Lego pieces, so the drawings then go to the machine shop, and they've got to buy the material, and they've got to machine all the little pieces that make up their own little Lego pieces. And then they've got to buy all the other bits, like the gears and the axles and the shafts and so on. And then they've got to put all that into a Lego box. And then the designers make the instructions and say, okay, well, here's the instructions and here's the pieces. And then they have to give it to the assembly guy, and the assembly guy has to basically put all the pieces that we made and bought and put together like the instructions said. And then the electrical guy comes in and says, okay, well now they've built it, now it needs to move, like the instructions say. And then they have to wire it up, and they've got to build the brains of this whole thing. And they put it all together, and eventually they push the power button, and the whole thing starts to move. It's not unlike those robotic Lego kits that you get. It's just, I think, a lot neater.
We deliver turnkey automated systems to the automotive industry, as well as the food, pharmaceutical, and medical industries. Vision-guided robots in new technology companies or new automotive companies are a company that's looking at everything's vision, everything's robots, operators don't touch stuff. And now we're taking that technology and putting it into other industries, the food industry, cosmetics, pharmaceutical, consumer goods, where those type of companies literally work on a workforce that's all hands-on. They're not used to that robotic end. So we can go into those type of companies now and say, we can do everything from the beginning to the end.
At Promation, we're an engineering firm that builds equipment for the requirement, right? So it's just like any other machine that's out there, function dictates design. You need to make sure that whatever you're providing, the customer could come to us, like I said before, a little tooling package. And that is the most important thing to that customer at that time. And it has to be the most important thing to us as an organization. And some people might just say that's tooling, but that's a solution for his problem. And that's how you bring, address his manufacturing challenge by providing a solution. We could do something as small as a tooling kit, or we could do a multi-million-dollar line that has multiple robots. Even scale it back, just operator enhanced automation. With the way things are changing with minimum wage right now, labor concerns, even being able to staff is a huge issue for people right now because everything's so busy with where we are in Ontario and what's going on in manufacturing. So even operator enhanced automation, if we can get from 4 operators to 1 operator being able to do that task and then repurpose those 3 resources somewhere else inside the plant to be able to do other functions, that's huge return and a solution for that customer.
I think especially at Promation, because we manufacture manufacturing systems, because we work so intimately with robotics. I think that's what's really exciting, is that we're getting all these new technologies that are being developed in schools. At its core, a robot is really just some sort of machine that does a task. And there's, like you said, there's kind of 3 facets to that. There's it's got to do something useful, so it's got to be able to perform the task. It's also it has to have some level of autonomy. It's got to be able to do something by itself. We can't hold its hand while it's doing something, otherwise it's not useful. And then there's always some sort of sensing and decision-making aspect involved.
I'm part of the manufacturing process for building and assembling tooling for Promation here. And it's like building Lego, pretty much. So it's a fun way of building things. When I was a kid, I built Lego. And now I'm building things in real life like Lego, but actual machinery and automated machinery. It's really cool. Through obviously the project manager and the coordinators come together with the designers, bring out the package to us. Everything's machined basically in-house or outside. And we get the drawing, the assembly drawing, and we put it all together, pneumatically, electrically, mechanically. And we put it all together according to the specs of the customer and to our design team. If you like assembling things like Legos back when you were younger, then this is what you want to do. This is what you want to be in. You want to assemble things with your hand, like working with your hands, problem solving, because there's a lot of problem solving. This job allows you to travel, see the world. I've visited Russia, I've visited Brazil, continental America, a lot of states, Germany, Austria. You get to work with a whole bunch of different people from different countries, different skill sets. You learn a lot of whole different skills from different plants and operations. Because you got to know almost a lot of mechanical applications to do this stuff. It's a really cool process. I like doing it.
I came to information about 3 years ago. I came here actually on a program that was training people to use CNC machines. So that's where I started off. I used a whole bunch of the CNCs, CNC lathes, mills, and I actually gravitated more towards manual machines because I kind of it's more satisfying. I felt like I was actually using my hands more as opposed to pushing a button, setting something up. And I guess that's what I liked more. I liked that aspect of using your hands more, and it felt like I was doing more actual critical thinking as well. When I'm doing something, I often get to see what happens with it. It's not just, like you go to some shops and you machine parts and they go out the door in a truck and that's it. You don't know what you're doing. Here I make parts and we actually see them assembled and we actually see what the next process is. So I'll make parts and then I'll actually see these guys put them together. And sometimes if they need help, I'll help them put it together and I'll see the parts that I've made going to do something. I went to college for things that are completely different. I studied a bit of law and I realized very quickly that office work is not for me. And in all the hobbies and things that I do, I realized I like using my hands and I thought, why can't I just mix those things? Why can't I work with my hands and have that be part of my career as well?
Manufacturing to the economy of any major nation is important, and the people that can help achieve that is also important. Now with the advent of technology and Internet of Things and automation and so on, that hasn't changed. The only thing that's changed is the ability to innovate and adapt. So there's even more of a burden now for people, kids or students or young adults moving into manufacturing, to not only know the skilled trade portion, but also knowing the technology behind it, knowing the computers, knowing the robotics, understanding how to use cloud data and machine learning and artificial intelligence to make that more intelligent. There's this fear that manufacturing is going to take jobs away, but actually the opposite's true, where we're going to need more efficient manufacturing, because we can't keep producing the same way we're producing things. We can't have the waste. The environment can't take it. We need energy efficiency, material efficiency, labor efficiency, and so on, because we need this green economy, and the green economy requires us to be innovative on the total life cycle of things, and everyone has a role to play in that. So it's not that jobs are necessarily being taken away, it's that the jobs are evolving and putting more of a demand on the ability for employees, prospective employees, to bring with them the best of what they understand from their own generational experiences of current ways of behaving with technology and traditional manufacturing technologies and techniques. That's what our generation is going to need, is that next generation to bring that in, because frankly they're growing up in it, whereas we need to learn it.